So I think we had started talking about carboxylic acids, that they were like relatively the strongest of the weakest acids. They had typical acid properties. They would lose the H plus one. Why would they lose the H plus one? Because when the H is lost, they had an electronegative oxygen next door, which would pull the electron density away from it, and the negative charge would be lesser, which is why the H plus one was not very strongly attracted to this O negative, which is why the H plus one would dissociate more. Okay, so that was the reason for that. We did talk about that, and we talked about earlier. We had talked about alcohols, why they were weak acids. Alcohols की जो story थी वो ये थी कि in alcohols you had this carbon chain. Like if I have an alcohol, it's got this carbon chain. There is no electron withdrawing effect. So if an alcohol OH breaks and H plus one is lost, the carbon chain has an electron donating effect, which is why the H plus one would be very strongly attracted back to the O negative, which is why it would be very hard for it to dissociate. ठीक है? ये सारा clear है? Yes or no? Is this clear?
Yes, sir.
Yes, sir.
Yes, sir.
Achha, so we had now started talking about phenols, right? I just gave you a brief introduction of what phenols were. Phenols were a benzene with an OH. Okay? These are not alcohols. These are different from alcohols. It's a separate functional group, which is known as, this is known as a phenol. So what does a phenol do? It dissociates in exactly the OH dissociates in the same way. So we were talking about the structure of this benzene ring, and I told you that it's like a hexagonal ring-like structure where every carbon atom is making a double bond. Each carbon atom is identical. Each one of them is making a double bond. And I told you that when carbon is making a double bond, that means carbon is bonded to 3 atoms. So you have these 3 atoms. Like if you look at the carbon, the middle one over here, this carbon is bonded to 3 atoms. Every carbon atom is actually bonded to 3 atoms. So what that means is that carbon has 4 electrons, which means that out of the 4 electrons, 3 are bonded. One is getting attracted by one atom, the other one is getting attracted to another atom, and the third one is getting attracted to the third atom. So the fourth electron is not initially attracted to anything. Okay? So that's not attracted to anything initially at the beginning. And because of that, what happens is that since every carbon atom is similar to this, it's बल्कि यहाँ पे I can draw this whole thing again just for explanation. So every carbon atom is making 3 bonds. This carbon atom is also making 3 bonds. This carbon atom is also making 3 bonds. This is also making 3 bonds. So every carbon atom that you meet is making 3 bonds, and there are hydrogen atoms on the outside. And for every carbon atom, there's a 4th electron which is not doing anything. Okay, so there's an orbital which is still, it has room for 1 more electron. So the 4th electron is not doing anything whatsoever. So what eventually happens is that all these extra p orbitals, they start to overlap. They can form pi bonds, 3 of them, which means 3 double bonds are formed alternatingly. They can start to overlap with each other. But eventually what happens is they all start overlapping with each other. So the whole pi electron cloud, the double bonds, they kind of get mixed up. And there's an electron cloud above and below each carbon atom, right? So the double bonds get delocalized. The pi electron cloud gets delocalized. That's known as a pi electron cloud, obviously. Or you can call it a benzene ring. ठीक है? Is this clear?
Yes, sir.
Yes.
So that's your benzene ring. So which is why the Kikuele structure is kind of an oversimplification. It's not actually. I mean, they use this structure, but always think of the double bond as being delocalized, like all the electron clouds getting mixed up, and you have this pi electron cloud. Now, one thing about this pi electron cloud is this one over here that you can see. One thing that's wrong with this is that it has. One second. One thing that's wrong with this is that the electrons are very distributed. Like the one that I'm shading, this electron over here in this p orbital. Not only is it overlapping on the right side, but it's also overlapping on the left side. So at the end of the day, this thing has low electron density, which means that the electrons are very distributed over a very large area. So they're very distributed. So the electron density is not really, it's not really very high. So the electron cloud, because this p orbital, not only is it overlapping on the right, but it's also overlapping on the left side. So the electrons are kind of not concentrated at a particular point. Like if it had been a double bond, then the electron density would be very concentrated at this particular point. But since the electron density gets spread out over the entire benzene ring, which is why the electron density decreases. ये point be clear?
Yes, sir.
Yes.
Achha, so remember the electron density is not really high, and electrons are very distributed. So if you have a phenol में क्या होगा कि the H, there's not going to be, one of the H would actually be an OH. ठीक है, so that is what a phenol is. It's a benzene with an OH. Just a second. So it's a benzene with an OH, and the O has these lone pairs. Like these lone pairs have high electron density. So that's an OH. And obviously, when it dissociates, the H kind of breaks away. It turns into an H plus 1. So that H plus 1 is going to be lost. That's what's going to happen. And there's going to be minus 1 charge over here. So H would lose its electrons as well to O. So there's going to be a very large negative charge over here, like in every case above. What would happen now is there's a high concentration of negative charge. This negative charge, what it does is that over here you've got low electron density. So the electrons from this oxygen, they start overlapping with benzene's electron cloud, and they start to kind of get distributed or mixed up with the benzene electron cloud. So lone pairs on oxygen overlap with benzenes so they overlap with benzene's pi electron cloud. Okay, so they're overlapping with the pi electron cloud, and which decreases electron density on this phenoxide ion, which is C6H5. So this electron density kind of that becomes lesser, C6H5 O minus 1 ion. So that electron density is decreased, and the ion becomes stable. And more dissociation happens. So this is what the structure of benzene does. has an electron withdrawing effect because it has a large surface area, and the electrons over here can get distributed over a large area. There's an electron cloud, so the electrons over here can kind of get mixed up with that electron cloud, so the electrons can get distributed. Is this clear?
Yes, sir.
So hence, it's a stronger acid compared to alcohols. So you've got a much stronger acid compared to alcohols. So which is why phenols are kind of in the middle. They're stronger than alcohols because they have some electron withdrawing effect. I mean, over here, so what I can do is I can start. In alcohols, you've got an electron donating effect. In phenols, you have this slight electron withdrawing effect. And the last one, you've got a large, because of the electronegative oxygen, you've got a large electron withdrawing effect going on. Okay, everyone, is this clear?
Yes, sir.
Yes, sir.
So remember these explanations, which I'm going to put this in a box as well. So remember this explanation, and hopefully the structure of benzene. We're going to study this structure, and we're going to discuss this again later on as well when we do organic chemistry. But since most questions would have this, so we'll discuss it. I'm trying to discuss it right now. Now the next thing is we're also going to talk about bases. So as another question is, what about bases? And we are comparing nitrogen bases. Okay, so this is going to be a comparison of those bases. Nitrogen bases. The issue with nitrogen bases is that they are. Why is nitrogen compounds basic? That's the first thing. Now, before that, I'll just list something down that you've got 4 types of nitrogen compounds, if you include ammonia as well. So they are amides, like this is what an amide group is. So then you've got phenylamine, which is basically and then you've got we can include ammonia, NH3, and the last one is an alkylamine, which is a carbon chain with NH2. So that's your alkyl amine. This one is a phenyl amine. It's a benzene with an amine. So you've got, and that's the middle one is your ammonia. So the first one is not basic. And then when you move to the right, so as you move to the right, the basicity starts to increase. So moving to the right, they become more basic. So the first one is not basic at all, but when you move to the right, they become basic. What is a base? Base is something that accepts H plus one ions. So we expect all nitrogen compounds to be actually basic. Uh, we want to think that they do accept H plus one ions, but why would nitrogen gain H plus one ions? So I'm going to start with ammonia. Let's talk about ammonia. Why is ammonia so basic? So ammonia has N with 3 H's, and it's got this lone pair. So it has this lone pair. So if there's an H plus one that's roaming around, so you have this this H plus one, and that's roaming around, there's a lone pair, then obviously they're going to get attracted. The lone pair has a high charge density, and it's capable of forming dative bonds. So the H plus one and the N and N lone pairs are going to get attracted. So that would result in the formation of a dative bond, which is going to be, so that's going to be this one. It's going to be N lone pairs getting attracted to H positive ions. Okay, so it's capable, the lone pairs are capable of accepting H plus one ions. Ye bhi clear hai?
Yes, sir.
Yeah.
So your lone pairs, they accept H positive ions, and they form dative bonds when they do that, or coordinate bonds, dative covalent bonds. So they do that when they bond with them. Now the question is, what explains the difference? Like, why is this the most basic, and why are the others less basic? So let's start with alkylamines. I'll just copy this. So alkylamines, what's wrong with them? What's wrong with them is that why are they more basic compared to the others? What's wrong with them is that they've got this carbon chain. N has these lone pairs, right? And it's got this alkyl chain, this carbon chain. Carbon chain has an electron donating effect, which makes the lone pair electron density higher. So alkyl chain, so that's your explanation. So which increases negative charge density on the lone pair. So higher charge density on the lone pair on N, and because of that, there's going to be more attraction for H plus one ions. So it's going to have a lot more attraction for H plus one ions. So this is what this alkyl chain would do. Is this clear?
Yes, sir.
Yes.
So then I told you about, we did discuss benzene right now. Why is benzene less basic? Because it's the same reason why it's less basic, because benzene electron density is slightly lesser. So the lone pairs over here would start overlapping. So in this case, you have NH2, it's phenylamine. So let's copy this. So what's wrong with phenylamines? So phenylamines, again, as we discussed, lone pairs on N would eventually merge or overlap or get spread out over the benzene electron cloud. So the lone pairs on N they overlap with benzene's pi electron cloud or the benzene ring, which is why the charge density becomes lesser, so that decreases charge density. And there's going to be less attraction for H plus ions. So it's obviously going to be less basic. Okay, so the basicity would be lesser compared to normal alkylamines or even ammonia. And the last one is why amides not basic at all? Amides have literally have no basic character. I mean, they're incapable of attracting H plus one ions. So what's wrong with them? ठीक है, अब इनके साथ the issue is कि so this is my amide. Now, in this case, what happens is like if you have an amide, there's a highly electronegative oxygen next door. So what happens is that oxygen completely withdraws this electron and mixes those electrons with its double bond. So the electrons over here, the lone pairs, are not even available in the first place because the withdrawing effect is so strong. So the explanation for this would be that you've got this neighboring highly electronegative oxygen in C double bond O has a strong electron withdrawing effect. So there's a pretty strong electron withdrawing effect, which is why lone pair charge density is almost negligible. So they are hardly present because they've all gotten attracted and are pulled towards that oxygen. So strong electron withdrawing effect, and we should lone pair charge density overlaps with the pi electron cloud in C double bond O. And therefore there is no attraction for H plus ions because they're not even there. Okay, so it's not basic. So is all of this clear?
Yes, sir.
Yes.
Acha, so just remember that's the first thing, okay? So the idea is, I mean the basic idea is, if I want to summarize this and summarize the whole acid-base concept. So the idea is whenever you have an electron donating effect, or you've got an electron donating group attached, what's going to happen is that the acid would become weaker. Just hold on 1 second. अच्छा चलो ठीक है so this one I was saying कि electron whenever you have an electron donating group attached to an OH ठीक है so that means it's going to be a weaker acid ठीक है that's one thing बल्कि ignore OH I mean whatever we studied that's the summary that whenever there's an electron donating group we get a weaker acid but if it's attached to a base then you get a stronger base. For example, out of the three, you've got alkyl chain attached to NH2. That means K alkyl has an electron donating group, and which is why the charge density increases and it becomes a stronger base. But on the other hand, if you have an alkyl chain like in an alcohols, ठीक है, alcohols में हमने ये किया था कि if you have an alcohol and there's an electron donating effect, तो negative charge ज़्यादा हो जाता है, which is why it pulls the H plus one back again. It doesn't really dissociate. ठीक है, is this clear?
Yes, sir.
So so the idea, I mean, that's the whole summary. And or vice versa, if you've got an electron withdrawing group, तो उल्टा होगा कि the acid would become a stronger acid. And if you're talking or discussing a base, it's going to become a weaker base. ठीक है, is this clear?
Yes, sir.
Yes, sir.
And you would also get questions which are comparing carboxylic acids. For example, you have this carboxylic acid CH3. So we're going to start comparing carboxylic acids. And we've got this other carboxylic acid, which is CH3, CH2. Which one do you think is the stronger of the two acids?
The right one, sir. The left one, sir.
I mean, this one has a bigger alkyl chain, so it means it's got a bigger electron donating effect. This one has a smaller electron donating effect. So if you have a bigger electron donating effect, it's going to become a weaker acid. This one is going to be a weaker acid. Whereas this one would be relatively be a stronger acid. And why would that happen? Because when the H is lost, so both of them, let's assume that they dissociate and they ionize and they produce this negative ion, this one also a negative ion, and let's assume that the H plus one has dissociated. So who's going to, this one, this acid will have a much, I mean this one over here, this acid will have a much bigger negative charge because there's more electron donating effect. And the negative charge density over here would be a lot larger. So the H plus one is going to get attracted back again, and it's not going to dissociate. Is this clear?
Yes, sir.
Yes.
So then other comparisons. Let's say we have. So let's say we have an acid where you have. So I've got three acids. All of them are carboxylic acid. So I've got this one. I've got so there's this one as well. And there's this one. अब इनमें बताओ कि which one do you think is The weakest acid, which one is the strongest acid? Which one has electron donating effect or withdrawing effect? Like, what does the Cl do? I mean, the Cl is the only thing that's new. Otherwise, they have the same number of carbon atoms. So, what does the Cl do? Electron withdrawing or donating effect? क्या होगा anyone? Shafak? Aruba? लुबेना इसका क्या होगा? किसी को आता है? Yes or no? Can you hear me?
Yes,
जी।
sir. The left one.
क्या होगा? This is strong or weak?
Strong.
ठीक है, it's going to be strong. Okay, let's assume के अच्छा weakest कौन सा होगा out of all of them? Like, let's assume के the H is lost in each one of them. Which one out of the three would be the weakest? Like, the H is lost? Or इसका भी H plus one is lost. So ये बताओ कि weakest कौन सा इन सारों में?
The left.
अच्छा ये पहले ना Cl का ना electron withdrawing effect है, ठीक है? So the Cl would be what it would be doing is withdrawing electrons. Like, I mean, you know that Cl is electronegative, right? Here's another
Yes.
Cl. अच्छा, here's another Cl. It's going to have an electron withdrawing effect. So in दोनों cases में तो negative charge density क्या होगी? It's going to be lesser, right? It's going to be a lot lesser. The negative charge density over here would also be a lot lesser because, and if it's lesser, it's not going to attract the H plus one back again. So more dissociation would happen. Is this clear?
Yes, sir.
अच्छा, और इस case में ना there's only one thing and that's your carbon chain. Carbon chain का effect क्या होता है? That's an electron donating effect. तो वो donate करेगा and the negative charge over here would kind of increase and the H plus one would be pulled back. There's going to be less dissociation in this case. ठीक है, so this one is going to be the weakest. Why? Because there's only an electron donating alkyl chain. There's no withdrawing effect. ये clear है सारों को? Yes or no?
Yes.
Achha, then these two are going to be good acids. These are relatively going to be stronger because the negative charge would be lesser, negative charge would be lesser. In दोनों में compare करो, which one is going to be the weakest out of the two? Yeah, which one has more electron withdrawing effect? I mean, the two Cl, Cl over here and there's a Cl over here.
The left one will have a stronger withdrawing effect.
This one.
Yeah.
So remember, this Cl is very far away from this oxygen. So would it have a stronger withdrawing effect or would it have a lesser withdrawing effect?
Lesser.
ठीक है, because it's really far away. So I mean the withdrawing effect is the same. Like it's both cases it's Cl, but since this Cl is very far away, so its ability to pull the electrons away from this oxygen, that's kind of it's going to diminish, right? So Cl is far away. So your electron withdrawing effect diminishes. Is lesser. Over here, you've got Cl close to the COO minus one group. So there's more electron withdrawing effect. So there's going to be more electron withdrawing effect, and it's going to be a stronger. So this one is going to be a stronger acid. So ये clear है?
Yes.
sir.
अच्छा ये हो गया. अब है कि so remember, you can get all sorts of questions. What you need to understand is the concept, because I mean you can get all sorts of questions. You can get acids that you haven't even studied, which are not even in your course, and they would ask you about their strength as acids. So it all depends on the negative charge that is appearing on the acid. If a donating group is attached, then it's going to be a weaker acid. If a withdrawing group is attached, it's going to be a stronger acid. How do we figure out which one is the donating group, which one is the withdrawing group? Just give me 1 second. Okay, time ho gaya. So we'll continue with this. Okay, we're done with this whole equilibria thing. We'll just do past paper questions now and try and solve past paper questions from the next class then. Okay? ये बात clear है सारों को?
Yes,
sir.
but sir, I have one question. If
Yes.
there's a double bond between the acids or the bases, will it affect their strength
Like a double bond in what way?
in the carbons, between the carbons?
It possibly can, yes. But I mean that double bond, it's like for example, you're talking about it this way, right? You've got this thing, right?
Yes.
Yeah, but the double bond I don't think it's going to have that much of an effect. I mean, they're not going to be very detail oriented. It's not going to be very, I mean, the questions would be very clear. It's like, just remember carbon chains have an electron donating effect. And if you have chlorine or any other group attached, like an electronegative atom, then it's going to have an electron withdrawing effect. Ye clear hai? I mean, because
Yes.
because everything is going to have some effect, right? So the question would be kind of more straightforward. It's so that you can easily kind of guess whether there's electron withdrawing or donating effect. Okay?
Okay.
So let's continue tomorrow. Okay, Allah Hafiz.
Allah Hafiz.